Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about our virtual machine. So in the previous episode, we talked about how to create a garbage collector. So we're basically just going to be going through the entire code base in terms of how the execution would actually flow when our programming language starts. So to recap, whoops, I'm not going to do that. So if I go to the main in here, in the runtime, this represents the start of our runtime, and of course we initialize a garbage collector. Also, guys, I ended up realizing something pretty crazy. So this fix actually gave me, I think, a 10 to 20% improvement in performance, which was very weird because it was a very simple fix. Basically, I had the memory threshold originally at, I believe, 64 kilobytes. That is entirely too little. Because if you guys remember, our default heap limit is, I don't need this anymore. Our default heap limit is 64 megabytes. So 64 kilobytes is only a fraction of the amount of 64 kilobytes. So I ended up doing 12 megabytes as a threshold because if you remember, every time we do a collection, when we go to collect garbage, and whenever we call this function, I'm not going to look for it, but basically whenever we try to call this collection function, we want to collect based on whether or not we've passed that threshold. And if your threshold starts out as 64 kilobytes, that means that if you are basically allocating anything over 64 kilobytes of memory, you're going to get a collection, which is pretty ridiculous. So we're back here now. Finally, we've come full circle where we talked about the garbage collector and the multi-threading platform. We want to process our executable. Now we've already gone over this, and of course we've already gone over, printing out the error message and the internal stack check. But now we're going to basically see where the startup actually happens. So the thread startup function, where we talked about starting up the main method, is called immediately in create virtual machine. And you want to start up the threading system before you start up the garbage collector. That's typically how I do it. Even though you're starting up the main method, you're not starting it. You're just creating it. So you shouldn't have any issues. And anything else you guys want to do to set up your multi-threading platform, you need to do that in startup. And then you can start up your garbage collector. So that just basically creates the garbage collector. And this actually starts it before. So you want to make sure that you start the garbage collector before the main function or the main thread, because obviously if you don't, that could potentially be a problem. So you want to make sure you do that. Now, after that, we will be going over the GIT eventually. I have a ton of work to basically do to make all this stuff work, but you do want to also subsequently call the startup function for the GIT. And this function is located, where is that? That's in the GIT, git.cpp. And the startup function in here does a set of checks, and we basically check to see if the current compiler options or the C options is enabled, meaning that we want to run the JIT, and then we do some checks here. So like I said, we'll go over the JIT a little bit later, but if you want and you want to build your JIT ahead of time, you can create this JIT class, which will basically contain that startup function. I have a few functions for the JIT. I have the startup, the shutdown, the TLS setup, and a few others. You guys can check it out. This is the main interface for the JIT, and then I have lower level interfaces as well. And we'll get into how this stuff is structured later on. It's actually structured kind of nice. But to keep things simple, I don't want to talk about JITs right now because that'll be too long of a video. Now we're ready to set up our exception classes. So what these are going to be frequently used classes that we're going to be using throughout the execution of our programming language. As our programming language is running, we may internally get a null pointer exception, an out of memory exception, or various other errors that we may receive. We also may want to initialize a class like string class, a stack state, a thread class, or an exception class. So again, I know I've mentioned this before, but always remember to add these various different classes to your dependency file. And where's that at? That's in the platform and dependencies. And this basically just protects from code obfuscation. So you want to just make sure you keep all of the required classes as well as the required modules that you need for each class. Because even though you keep the class, the module can also get obfuscated as well. So just make sure you do that. That's very important. And let's see, so if we go back to virtual machine, so now that you create these, now these are going to be very specific to my programming language. You may or may not need to have all of these. It completely depends on how your language is actually going to run. So if you're going to have, obviously throwables, maybe it's named a different name. If you're going to have string classes or whatever, then it just is really going to depend on a case-by-case basis. So I created this resolve class function where you pass in the full name of the class, so you have to pass in the module and then the actual name of the class. And what this does is just a simple function that does a for loop of the total classes listed in the manifest. So we're going to get that total class count from the manifest, and then look at the vm.classes pointer here, and we can just basically inspect all of those pointers. And if the full name matches the full name that we passed in here, then we return a reference to that actual class object, which is then going to allow us to do whatever we need to do on that class object. So you just want to make sure you have those pointers, and you want to do this once at the very beginning because it just makes things a lot faster, because you don't want to be resolving these as your code is running. Because if you picture it, for instance, a perfect example is stack state. This stack state class is what I actually use to generate the state of the stack so that I can build exceptions properly. Now, if every time the user thrown an exception, I ended up having to resolve this class, that would slow down the programming language for every time an exception is thrown. So you want to make sure that your virtual machine is as efficient as possible so that it can work. You also want to set your cout precision to 16. So this basically means that the maximum amount of output bits is going to be 16 bits for doubles. Since I use doubles for everything, that's why I have it. So we're going to basically create this object. So now here's the first example of where we see how objects are actually created in the garbage collector. So we're going to pass in the reference to the class pointer of out of memory exception, and we're going to take that in here. Now this new object function, I have a couple different new object functions. Basically this one's for classes, so you pass in the class and then whether or not it's a static initialization. Now the way I create classes is I basically call malloc, which basically calls this, and then it does our checks to make sure if we have enough memory. Now this is how you would get an out of memory exception. If you try to allocate, a billion bytes and you only have maybe 35 kilobytes of space available, then we're going to basically throw an out of memory exception. So that's kind of how it works. It's a really nice way for us to basically wrap the malloc function and to make things a lot easier so we could track data. So then we get the size based on whatever it is. So if it's a static initialization, we want to get the static fields. Otherwise, we want to get the instance fields. Then you want to initialize your object by passing in the size in the class, which calls this function, which sets this up as a data structure or class object. Of course, we set the class bit as well because this is a class. So after that, we want to check to see if the size is greater than 0, because obviously you can have empty classes. That's not really an issue. So if we have fields in the class, then we want to get our node. So we want to say node is equal to calloc of array of objects. So we want to create an array of objects which are going to represent the node or the structured data of our class. And the way it's going to work is for objects, we're going to have, object 1, object 2, object 3, and within each object, we're going to have, 0x, whatever, as the address of the first sharp object, 0x whatever as the address of the second, and of course 0x whatever as the address of the third. So that's kind of how it works. You don't want to create an array of sharp objects specifically, because that would basically force you to have to create the objects on the actual data structure. You want to detach them and have them as pointers, because the garbage collector is going to be responsible for freeing up these pointers. So just keep that in mind. That's kind of how I do it. So here's how I basically initialize it. So here's our first example. Let's say if I go to enum, right? Enum, I have this field called ordinal. Now, if any of you guys have ever programmed in Java, I'm pretty sure you know if you access an array object, or let's see if I have a different one. Do I have, let's say like, no, yeah, I guess it's an example. So for the string class, I have this data field, right? Once I initialize this class, if I try to do something on the data class, I'm pretty sure if you've programmed in Java, you'll know that you'll get a null pointer exception. That's because the actual object is null because it hasn't been assigned an object yet. However, if you do something like assigning an integer value in that actual object, it works just fine. You don't get a null pointer exception. So we're going to have to follow that same model where we basically, all these are technically objects, right? So we're only going to allocate the numeric values or the numeric objects at the start. So what we end up doing is we basically have to pick where we want to start. So the way that I do my addressing is I basically address all of my instance fields first and then my static fields second. So then that way it's a lot easier for me to basically allocate the fields and do it properly. So what I do is I just for loop through the size of the object and I check to see if the field's type is less than or equal to a var, meaning that is this field a number? And then I also check to see if it's not an array, and then I check to see if it's not a static initialization, or if it is a static initialization and the field is in fact static, then I basically assign object at that node equal to a new object of 1. And what this does is we basically create a size where we, create an object. It is a var type or a number type. We set the head equal to whatever the size is, and you want to call calloc, by the way. That way you don't have to initialize it yourself. It just auto initializes. And then we set the s type to var. Am I actually doing that twice? That is weird. Okay, so don't need to do that. But basically you want to track the allocation amount. So this is where you get to see like why I was having some issues with the garbage collector running in real time. So basically we guard the mutex and then we update the managed bytes value based on whatever we allocated. But then we want to push this object onto the memory. So the way that I add objects to the memory is I increase the heap size, which again is an atomic integer, so you don't have any issues. Then I say the tail's next object is equal to this object, and then I re-update the tail. So this is why you never want to touch the tail, because the tail's always going to be changing. So you want to stop an object before the tail, so that way you don't have any issues. So if I go back, and of course this is assumed to be a young object because it's just being born. So I add young objects to one more, and then I update the heap size. Didn't I just do that here? Okay, that's weird. So I don't need to do that anymore. So I'm going to remove that for all of these. That is very strange. But yeah, so that's kind of how I do that. Now, if I go back up to here where we're creating a class, so that's basically how you can not get a null point exception when you access a variable, because you're actually just allocating that as soon as the class is created. Then of course I plus my field addresses so that I'm in line with the current field that we need to process. And I do the same thing I do down here. So I guard the mutex, update the managed bytes, push the object to the memory, and then I say young objects plus and return the object. So that's how we basically create an object. Now let's go over the other object creations as well, just so we can get it out of the way. So we already went over how to create a number. Here's how you create an object unsafe. Basically, this doesn't use the memory system. So we basically create a numeric object without, it's the exact same thing as this function. The only difference is that I do not call the underscore malloc and the underscore calloc. So it doesn't cause an exception. And I just basically do a couple more checks to see if those values are not equal to null. So we do that, and that's how we do that. We went over that function. We also have a new object array. So if we want to have a data structure, but maybe it's not a class, maybe it's just an array of just random objects, right? It's not really tied to anything. Then we create a sharp object of a type structure, and we assign the node equal to the size of the value here. And then we guard the mutex and just add it like everything else. Now, if we want to create an array of classes, however, then we basically want to assign that object here, initialize it as a class with the size, and then, check to see if the size is greater than 1, update the node, and then push this on to the memory. So that's going to be pretty much how we allocate memory in the actual programming language. So if I go back, where were we? So go back here. And then, so that's pretty much it. And then we also want to create a string array of message. So I create a message saying out of memory, and I create a string array, and I resolve the field. So first, let's look at create string array. So you want to pass in an object pointer and whatever the string is that you want to initialize. So I basically assign that object pointer equal to the new object. And remember, guys, this is always, every time we assign an object, we are calling these functions. And each of these functions, all they do is just basically check to see if the current data that we're assigning here is equal to the current instance, or the object that we're being assigned is also equal to the same object. Then we obviously don't need to update anything and we just return. Otherwise, we decrement the reference and then we add the object to the current object that we have. So that's going to be how we do that. And then let's see. So if we go back, whenever we create strings, we want to just basically for loop the entire string and just add, those chars to that string. So we create an object based on the length of the string and we just basically create a string. Now, because it's a double, we can't just do an std memory copy because that's not going to work. So we just do it physically like this. It's a little bit more inefficient, but I haven't had any issues and my language is pretty fast as it is. So if I go back, so once we do that, then we want to actually resolve the field. So here's how we resolve fields at the runtime. So you want to create this resolve field function, pass it the name and the actual sharp object, or of the class that you want to resolve. So I check to see if that class object is not equal to null and that it is in fact a class. All this does is it checks the class bit, and if that is enabled, then we're good to go. Then we want to get the represented class of that. So we get the class that is inside the info and we get the address of that, and then we basically just for loop through the total field count of that class and we try to locate the field that matches the name that we passed up here. So we look for the field. If we have the name, then we need to do one more check. We can't just return the value, right? Because static fields and instance fields have two different types of addressing. So if we pass it a static class but yet we're trying to access an instance field, we're not going to be able to do that. So what I do is I check to see if this is a static object, and I basically check to see if the generation is equal to generation permanent. The only objects in my entire programming language that will ever have a permanent generation are static objects. So that's how I basically verify that. And then once we have that, then we also want to check to see if that is equal to whether or not this is in fact a static field. So if this class is not a static class and this is not a static field, then we basically return the node or the object at the address of the field that we're at. Otherwise, we return null. And otherwise, if we never get through any of those, we just return null. So that's how we resolve fields in the programming language. And let's see, so if we go back. So once we do that, now it's time to initialize our entire static space. And this is what I was talking about where I say static classes have a permanent generation. Basically, all I do is I for loop through the entire amount of classes, and I create a new object of a class, and I do a static initialization of true. And then I just immediately set the generation to a permanent generation. And these will be the only classes that have that permanent generation. And guys, keep in mind, if you take a field and assign it a value inside of this permanent class, that field will not be a permanent object. So the only thing that is keeping that field alive is simply the fact that this object itself is in fact a permanent generation. You don't want the class as well as the subsequent fields in there to be all permanent generations, because then you won't be able to properly access the data properly. So just keep that in mind, and that's pretty much it, guys. So that's how you create a virtual machine. We've basically gone over the entire function for doing that. So now if we go back to our main, we're done. So we've created our virtual machine successfully, and now we're ready to actually start our program. So now we're going to just start getting into execution. So how do we actually execute our program? Believe it or not, we're actually very close to doing that. So that's going to be it for today, guys. Hope you enjoyed the video. As usual, if you have any questions, as always, put them in the comment section below. And of course, if you guys would love to help support the channel, you can always head over to my GitHub repository at androidevcd/sharp. When you do, definitely watch, star, and fork this repository. That gives this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about some of the stuff that I'm looking to add in the future, there's been some updates. So with the roadmap, this kind of shows basically all the various things that I'm looking to add in the future to the language and improve it. And I'm actually working on the Sharp Native Bridge right now. There's some things that I want to do to just make it a lot better of an experience. So like I said, hopefully this will be done before we get to it. And yeah, so that's going to be it for today. As usual, if you're new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.